Okay, if you're on Schoology, you should be looking for the notes posted for today, and today is 12-3. So here's the first problem that you run into, and it's factor that. Now this one starts off fairly easy because you can factor this the way you've always factored things. Take two sets of parentheses, and you figure out what would go here and here. That would make x to the fourth. That's pretty easy. What would it be? X squared and x squared. And then you figure out something that multiplies to this and adds to that. So 4 and 2. And should I make it, which one's positive? All right, well, somebody said the 2, somebody said the 4. I'm going to try it this way and see what happens. Okay, how do I tell if I'm right? I check outside and inside, and I see if I really get what I wanted, and I do. So this must be the right one. Okay, so always double check yourself like that. Check outside and inside. That makes 4x squared, that makes negative 2x squared, and that adds up to positive 2x squared, so I know I did it right. Okay, any questions on that one? That's kind of easy stuff. All right, get to the next problem. And I want to take just a second and show me that you've got this on your screen right now. Back to recording again. Everybody take this one, start by factoring the 2 out, and then see if you can factor it. I'm going to help the kid with their internet issues here for a second. I'm going to pause. Okay, so I'm back, and you're factoring out that 2, kind of like this. And then it can be factored the rest of the way. X squared and x squared. Do you see what to do? What would multiply to 18 and add to 7? 9 and a 2. Okay, so I use a 9 and a 2, and then it's only a matter of which one should be positive and which one should be negative. The 9's the one should be negative. How do I know that for sure? Because if I go outside, that makes positive 2. Inside, negative 9. Together, they would make negative 7, so I did it right. Now, how many of you had this one the way I had this one? All right, good. Anybody got something even smarter? Because that answer is actually not right. And why? Because when you're factoring, you want to factor all the way. Yes? The x squared minus 9, you could factor out further. Do you remember that's called the difference of squares, and therefore can be broken up into 2 sets of parentheses, x, and what do you think? Minus 3 and plus 3. Do you remember that? And I just dropped the last one down, and this one right here, it's so easy to forget that that's called a difference of squares and can be factored into that and that. So there's my final answer. It's factored all the way now. And now here's the thing that we are teaching you tomorrow, because I'm going to teach you it today so that we can basically have more work time tomorrow. All it is these equations are supposed to have 4 answers because there's a 4 there. What are the 4 answers? Well, one of them is here, setting that equal to 0. Set the whole thing equal to 0. So either this has to be 0, or that has to be 0, or that has to be 0, and can 2 ever be 0? No. So that doesn't do anything out there. All right, so here's my answers. X minus 3 has to equal 0, so x has to equal 3. And x plus 3 has to equal 0, so x has to equal negative 3. 1 answer, 2 answers. But wait a minute. How can you get that to equal 0? Nope. If I say x squared plus 2 equals 0, I can't do it unless I do something really special. What do you think? You're close. You're saying it's slightly wrong. You are kind of right. Just tell me what to do next on this problem. Take off 2. Okay, so I take out 2, take off 2, and then I get x squared equals negative 2. And then how do you finish that? Square root of both sides, okay. And now what's the square root of negative 2? It's not 2. Absolute value of x. Do you remember that? The square root of x squared is absolute value of x. Gotta learn that. You're going to see that in free calc like a zillion times. It's not just x. It's the absolute value of x. And now how do I simplify this square root of -2 thing? You say I, because it's the square root of a negative. And now it'll be just a normal square root of 2. It's not 2. That would be if it was like square root of -4. Then the answer would be 2i. So the final answer is this splits into two things. The absolute value of x breaks into two parts. It's x equals I root 2. And the other part is x equals the opposite of I root 2. And I know you probably just want to say x is plus or minus I square root of 2. Whew. Hardcore stuff. You've done it before, though. The only new stuff here is that you factored something that had an x to the 4th in it. And what are my answers again? This one for that. This one's the answer for that. Wait, I'm almost done here. 1, 2. And then what's that? How many answers is that right there? 2 answers there for that. There's 4 answers, just like we wanted. 1 answer, 2 answers, 3, 4 answers. All right. Let's go on to the next screen. This one, factor, just normal factoring. Do you get that there's an x in everything, though? Factor that out first. Factor that x out first. And then factor from there. Try to charge before you. I understand. Sometimes they'll be. What? Okay. All right. So a lot of you factored out the x and got this then. X squared plus 6x plus 9. And then most of you knew that you should keep going. X and x, and then how do I make a 9? 3 and a 3. Does that work with the positives? I double check it and I go first is x squared. Outside is 6x. Outside and inside together make 6x. And last make 9, and yay, I did it right. And what are my answers? That's the part B of the assignment for tomorrow. You just set this equal to 0. Set this part equal to 0. So x has to equal -3. 2 answers, and then how about that one? I can just jump to the -3 part. Here's 3 answers, just like I expect there to be 3 answers. All right. Are there any imaginaries in this one? No. When do imaginaries come up? When you have something like this, and you're trying to set it equal to 0. The only way that'll work if this part's -3. And if a squared thing has to become negative, that's impossible. So that's the kind where you'll have imaginaries. You have like x squared plus 27. Impossible. I can't make that equal 0. So therefore, I have to use imaginary numbers. All right, moving on to this one. This one's pretty easy. Just factor 4x out, and then it'll be piece of cake. Go for it. Every now and then, kids get stuck on this part, and we're going to come up to a tricky part in a minute where this will be important. So just go with me on this. When you're factoring out that 4x, do you get what you're really doing to each of these terms? I take out a 4x. What does that mean? Divide by 4x. Divide by 4x. Divide by 4x. That's how I get this part right here to be x squared. That's how I get this part right here to be negative, because it was -8 divided by 4 is -2, and the x squared over the x makes x. And that's how I get that part to be 1. All right. And why would I get this marked wrong? Even though I have factored it correctly, I haven't factored it what? All the way. And then 2 sets of parentheses, x, x, and what? Multiplies to 1 and adds to -2. -1 and -1. So are there 3 answers this time? Yes, but it's kind of weird. This one's 4x has to equal 0, so x has to equal 0. X plus 1 has to equal 0. No, x minus 1. X minus 1 has to equal 0, so x must be 1, and the other one's x must be 1. How is that 2 answers? It's a double root. So there's 3 answers, just like I would expect it. All right, moving on. This one, you know what? Skip E. Go to F. All right, this is the kind that you've never done before. There's a movie out that has a famous guy in it. His name is Abraham Lincoln. Heard of him? Have you heard of the movie Lincoln? Anybody actually seen the movie Lincoln? All right, did you like it? Good. Kind of historical, I'm assuming. I mean, assuming it wasn't like, he wasn't killing vampires in this one, was he? Okay, good. So anyway, Abraham Lincoln, he had a quote once. A house divided against itself cannot stand. He was talking about the United States. What dividing was he talking about? North versus South, right? And he basically was saying, if we divide up this country, we are going to become weak. He was right. If we had been divided into the North and the South in the United States, we wouldn't have been able to stand up to Russia, for instance. Okay, we would have probably never been able to help out in defeating Germany in World War II. We would have been so much weaker if we'd have been separate. And he was saying, a house divided against itself cannot stand. Another famous general, he was Alexander the Great. And his favorite saying when he was attacking a country was divide and conquer. Because he could divide off part of the country, conquer that army, and if he could convince them to not help each other, then he could have beaten them one at a time, because his army was way stronger than any one of their armies. For instance, if Hitler had been able to do this, if Hitler had been able to just take over one country at a time, his army was big enough. He was tough. I mean, Hitler's army was tough. The United States alone couldn't have taken him. No way. If they could have separated off and taken on Germany takes on, for instance, Russia all by themselves, they'd beat Russia. Germany takes on any part of Europe all by himself. England all by themselves, he'd have taken them. It was only because the United States joined with a whole bunch of other countries we were able to defeat Hitler. Otherwise, we'd all be speaking German right now. Seriously. So, bottom line is, if you can divide up and take on something little part at a time, it helps, and that's what we're going to do in this problem. You're probably wondering, why are we talking about history? Because we're going to divide this and conquer it. Because doing it in one chunk is impossible, but if we divide and conquer, it'll be easy. So ignore that part at the end. Just take the first part. Can you factor that? Yes, you can. What goes into everything? Of these two. There's nothing that goes into everything. That's why we can't factor it. So we're going to ignore that guy and say, what goes into both of these? Goes x squared goes into both of those. Yes, x goes in, but x squared is even better. So we take that out, and what would we have left? X plus 3. Okay. Now, watch what happens when we factor the other part. What goes into both of those? 2. And we factor out the 2, and what do we have left? X plus 3. Now, does anybody see what I'm going to do next? What do you think I'm going to do next? Yes. That put the x plus 3's together, but I'm not really putting them together. I'm factoring them out. You're used to factoring out like a number. I look in this and say, oh, there's a 2 in both of them. I'm looking at this, and I'm going to say, there's an x plus 3 in both of them. And that's going to come out to the front. And what will I have left? The reason I was reminding you what factoring really is it's dividing, right? Watch what happens when I divide this by x plus 3 and that by x plus 3. The x plus 3 cancels the other x plus 3. And what do I have left? X squared. And it cancels. Plus 2. There it is. And I would have really been disappointed if I hadn't gotten, one person said, oh snap, another person said, what? And another person was like, holy cow. So, I'd been disappointed if I hadn't got that, because that happens every single time I do this. It's so like, wait a minute, something weird happened, I don't know what's happened there. So, how about this? I know some of you followed it, but how about this? What's the true proof that I factored something correctly? Multiplying it back out. Watch what happens. I'm going to get rid of this extraneous mess here. And watch. First, what do firsts make? X cubed. What's the outside make? 2x. What's the inside make? 3x squared. What's the last make? See? It works. It's voodoo math. All right. So now let me show you how to do that again, except on a different problem. Move to the next page. It's gray. Oh, I'm sorry. On my screen it looks gray. I believe you. Your screens are much higher quality than my screen is. And if you were on the brand new iPad 4, it'd be like really amazing. Oh, that's right. They came out with new desktops on Friday, didn't they? I've been waiting. I'm thinking about buying one. The super thin table iMacs, yeah. The Chromebook. Those Chromebooks do look cool. If I was buying a laptop right now, I'd really look at one of those Chromebooks because they're so much cheaper than a laptop. So, all right, divide and conquer. Divide it like that. See if you can do it. Some of you are going to be able to handle this right off the bat, all by yourself. Focus. Ignore him, please. All right. That's a good question. If you don't take out the negative on the 8, if you like factor this just and factor an 8 out, not the negative, it won't work. So you need to do that right. So your first thought should be, what goes into both of these? X squared does. So then I factor it out and I get x plus 3. On the other side, what goes into both of those? And don't say 8. Negative 8. And if negative 8 comes out, then I will have x plus 3. That's the same as that. So therefore, it's got something in common, and I can factor it out, put it in the front. A lot of kids say, Mr. Server, why don't you put a squared on this? Because there were 2 of them. The reason we don't is whenever you factor something out, there's 2 of them. There were 2 8s. There was an 8 here and an 8 there. And when I factored the 8 out, listen. When I factored the 8 out here, I didn't have 2 of them. I didn't square it like this. The fact that there's 2 of them is because they're going to be multiplied twice by the parentheses like that. The whole distributive thing takes care of the fact that there's 2 of them. All right, so anyway, when you take that x plus 3 to the front, it's pretty easy. You know you're dividing by x plus 3. Do you get that that just makes this and this disappear? What do I have left? X squared minus 8. Raise your hand if you had that one right. Good. You've learned to divide and conquer. All right. Next one's a little harder, but I think somebody smart will tell us what we should do first. There it is. Take a 4 out of everything. Wait a minute. Minus 2x squared. Take a 4 out of everything. 4 comes out a 2x minus 4. There we go. Now, uh-oh, did I do something wrong? I think I did it right. Okay, and now you can divide and conquer. Divide it right down there. You still have this 4 out in the front. And then you need to see what comes out of both of these guys. See if you can do this. All by yourself. One of the signs that your kids are changing from being completely dependent on you. they would say, I do, I do. They wanted to do it themselves. That was a good sign. All right, so I'm going to factor x out of both, x squared out of both of those. And so then I have this x squared comes out here. That 4, I know it was separate, and it's going to bother you that it's by that x squared, but that's okay. And then I have, I'm going to move that 4 way over. It's even bothering me. I'm going to put it over here. It's still there, but we'll deal with that later. X squared comes out, and then what I have left, x minus 2. 2 comes out, x minus 2. Technically, that is a positive 2, so I might as well just put a plus there. And then the x minus 2's are in common. They come out to the front. And when they come out, what's left is this and that, x squared plus 2. And then don't forget the 4 that we had factored out at the very beginning. It's right there. It's really easy to forget that. And if they had asked you for an equation, you'd put a y equals, but notice the problem didn't even have a y equals on it. So all it said was factor, so we don't need a y equals. Okay. Is it factored all the way, though? Well, look at this. Can I factor anything out of that? No. This is the kind that has a minus, and it's supposed to have a difference of squares if you're going to be able to factor it, so that can't factor either. And a 4 cannot be factored any further, so it's done. It's factored all the way. Let me show you another way to do this. I'll do it really fast, but what if you hadn't ever noticed that that 4 could come out of everything? Can you imagine the kid starting this problem and saying, all right, I'm going to divide and conquer, so I go, what goes into both of those? 4x squared. And then what's left when I factor out a 4x squared? X minus 2. And then what comes out of both of those? 8. 8 comes out of both of those, and what do I have left? X minus 2. And now I have the x minus 2 in common, right? So I factor that out to the front, x minus 2. And then what do I have left? 4x squared plus 8. And it's really common for me to have to mark that wrong, because it's not factored all the way. See? This part right here has a 4 in it still. So I write x minus 2. That part was good. And then I put that 4 out, and then I have x squared plus 2. And now, if I put the 4 in the very front and say 4, and then x minus 2, and then x squared plus 2, then I'm really right. That's the same exact answer I had before. What's the difference? Just shows you that you can factor the 4 out at the beginning, or you can wait and factor it out later. But a lot of people would have never noticed and would have left it that way, and then they got it wrong. All right, one last thought. This is still not the answers. It's factored. But what are the answers? X equals 2 is one of them. That's the easy one. That one's going to be a imaginary deal, isn't it? So I'd say x squared plus 2 has to equal 0. So x squared has to equal negative 2. And so then the square root of both sides, and the long story short, it comes out to x equals plus and minus I root 2. Whew. All right, we'll do more of that tomorrow, though. So for right now, let's focus on the factoring, dividing, and conquering deal. And let's go to your worksheet. Everybody grab your Schoology. Look for the one that says today's date and says with extra space. Are you serious? Okay, I'm going to pause a second and fix that.